All right, look at us now in Unit 8. We are now in Unit 8, and I hope you looked at today's module really carefully, because today's lesson 1 in Unit 8 is actually a combo lesson 1 and 2. So lessons 1 and 2 are like 90% vocabulary. It's just getting to know some new words in statistics. So I decided to combine these two lessons because they are super straightforward and just about learning 4 vocabulary words. So we're just going to learn those. In lesson 1, there are 2 vocabulary words. Well, actually, I guess there are 3, so a total of 5. 3 vocabulary words in lesson 1. We're just going to learn those vocabulary words using the lesson summary page. So flip all the way to page 12. That's where we're going to start. We're not going to worry about all the lesson before that. We're just going to start with the lesson 1 summary that I believe begins on page 12. So flip there. We're just going to read through this first example here and talk about this vocabulary. Okay, so the very beginning of the lesson summary talks about this chart here. And this table contains data about 10 dogs. So notice, here's my dog's name: Duke, Coco, Pierre, Ginger, etc., 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 etc. In fact, I'm going to cover up the second set of headings. So we've got 10 dogs here. It also talks about their weights in kilograms. So Duke weighs 36 kilograms, Coco only weighs 6 kilograms, etc., etc., etc. Okay? It also tells us their breed. So Duke is a German Shepherd, Coco is a Pug, Pierre is also a Pug, etc., etc., etc. Okay? So there's our data that was collected about all these dogs. Okay? Now, it says down here that the weights of the dogs are an example of what's called numerical data. Okay, there's our first vocabulary word. Numerical, numbers, right? So the weights are numbers, as you notice. Number data is most often called numerical data, okay? Which is the data that are numbers, quantities, or measurements. So not only are these numbers, but as we know, weight is a measurement, right? The weights of the dogs are measurements in kilograms. So all of those weights are what are called numerical data, okay? On the other hand, though, it says the dog breeds are examples of categorical data, or categories. Notice, these are categories of dogs or breeds of dogs. We're just classifying these into categories, which is data containing values that can be sorted into categories. See how that works? So basically, the differences between numerical data and categorical data are that numerical data are numbers that we can do math to them, right? We could add up these weights and find out how much Duke, Coco, and Pierre weigh all together, right? Or we can figure out how much heavier Duke is than Coco. We can do math with numbers, can't we? Could I do the same thing with German Shepherds and Pugs and these categories? I can't do math with categories, right? I can't add up German Shepherd plus Pug plus Pug. That doesn't make sense. So categorical data are words, right? Categories, classifications, groups of things, right? And numerical data are numbers that we can do math with, okay? So those are the big differences between those two types of data that we can collect, okay? Now, there's one thing we need to know about some of the data that is also considered categorical. Oops, I didn't put the arrow to the wrong one. Categorical. Because categorical data actually can be numbers as long as those numbers are categories as well. For example, the numbers are not, some data with numbers are categorical because the numbers are not quantities or measurements. For example, telephone area codes. Do you know what a telephone area code is? The telephone area code for probably you here in Salt Lake County is 801, right? 801, yes, that's a number, but it's also a category. It's the area code for all people who live in Salt Lake County. Does that make sense? So it's actually a category. When I grew up with an area code of 435. That's a different category because I lived up in Logan, right? Logan's area code is 435. Now, am I really going to do math with area codes? Right? If I want to find the area code of Ogden, am I going to take 801 minus 435? No, that doesn't make any sense. That has nothing to do with Ogden's area code, right? These are categories. They just happen to be numbers. So we do have to be super careful with categorical data because sometimes they are numbers, right? But numerical data will never be words, okay? So categorical data can sometimes be numbers, but numerical data will never be words. It's kind of like the whole square rectangle thing, right? For those of you who know what I'm talking about, okay? So let's read that paragraph one more time just to be sure we understand it. Some data with numbers are categorical data because the numbers are not quantities or measurements. For example, telephone area codes are categorical data because the numbers are labels rather than quantities or measurements. We're not really measuring anything or counting anything, right? Those are just the labels we put on those area codes, okay? Numerical data can be represented with a dot plot. Now, numerical data is the only kind of data that we can put on a dot plot, sometimes called a line plot. In fact, I think you called them line plots in 5th grade, okay? I like calling them dot plots, though, because that's exactly what they are. We just always use dots. Sometimes line plots have X's instead of dots, right? But for our purposes this year, we're only going to use dots. So we just call them dot plots, okay? Numerical data, again, can be represented with a dot plot, sometimes called a line plot. Here is a dot plot that shows the weights of the dogs. So notice, 36 kilograms is that dot right there. See that? 6 kilograms would be that dot right there. 7 kilograms would be one of these dots. 35 would be one of these two dots. Now, why are there 2 dots on 35? Well, it's because 35 has 2 datas. 2 different dogs have the same weight. So both of their dots stack on top of each other. Why are there 3 dots here at 7? Well, it's because there's 1, 2, 3 dogs. 1, 2, 3 dogs that all weigh 7 kilograms. So these dot plots are super handy in organizing our data in a way. Oh, and you weren't able to see that dot plot. Oh my goodness gracious. I can't believe I had that so low. I apologize. I'm going to give you a second to look at that dot plot. Again, this dot plot you'll recognize is kind of like a line plot, but with dots, right? So here's my 3 dots for 7, my 2 dots for 35. You probably saw me circling them up here. So we just stack them on top of each other if there's more than one data value that matches that number. Okay, I'm sorry I had that too low. I hate it when I do that. We can collect and study both kinds of data by doing surveys or taking measurements. Okay, so those are the 2 ways of getting data. We can either take measurements like weighing the dogs, right? Or we can do a survey like ask their owner, what kind of a dog is Pierre? What kind of a dog is Pepper? And their answer would be categorical, right? So that's a survey. Surveys usually give us categorical data, although they can give us numerical data as well. And then, of course, taking measurements. The only thing we're going to do by taking measurements is we're going to get numerical data, right? So those are the 2 different ways of getting this data, either doing a survey or taking measurements. When we do, it is important to think about what feature we are studying. For example, breeds of dogs or weight of dogs, and what units of measurement are used. Like if I go up to somebody and say, my question is, tell me about your dog. They might give you 50 different things about their dog, but if really all you care about is how much does your dog weigh, then that's the question you need to ask in your survey, right? So this is part of what we're going to talk about in the next couple of lessons is what makes a good survey question and what makes a bad survey question. because we want our surveys to give us the answers that we can work with, right? So we're going to talk a lot about ways to set up surveys and to do measurements that give us good, strong data that we can then learn from, okay? Now, flipping to the next part, and I think, oh, that's the end of our summary page. So literally, that's all there was to lesson number 1, okay? Talking about these vocabulary words, numerical data, categorical data, and dot plot. What does this look like? We're going to use this information now in lesson 2, okay? It's just going to build upon this information. So that's where we're going to spend the bulk of our day today, is focusing on lesson 2, okay? Now, before I move on to lesson 2, though, I want to point out something about lesson 1's homework. On lesson 1's homework, you are only doing problems 1, 2, and 3, okay? But part 3, or number 3, does have a part B, so don't forget to do part B of number 3. But you do not have to do number 4. Again, that's from a lesson that we skipped, okay? So don't do number 4. You're just doing numbers 1, 2, and 3. And I will go over these after I go through number 2, lesson number 2, okay? So I will do those with you in just a few minutes, okay? But let's dive into lesson number 2, because this is where the bulk of what I want to talk about is going to be found, okay? Now, in lesson number 2, we are going to do all the activities in lesson number 2, okay? So if you haven't already looked at these, that's where we need to go next, okay? So lesson number 2 starts on page 18, and that's where we're at right now, okay? Activity number 1, pencils on a plot. Now, we are not actually going to do activity number 1. I forgot about this one. We're not going to do this one. And it actually says that in Canvas, and I just don't have that in front of me. I completely forgot. We are not going to take the time to measure our pencils and make, I'll do all this stuff with it, because of course we're not together. And I wish we were, but we can't do that. Okay. So we're just going to dive into activity number 2. Okay. Okay, so now with activity number 2, let's take a look at this table that we have. It says 10 6th grade students at a school were asked 5 survey questions. So these down here are the 5 different survey questions, but they don't want to tell us what those questions are, so they just labeled them A, B, C, D, and E. And then the 10 answers to the 10 questions go this way. Does that kind of make sense? Okay, what we're supposed to do in number 1 is match these 5 questions to the answers. So we're trying to figure out, is data set A question 1 or question 2 or question 5? Which question matches data set A's 10 answers? Okay, so let's look at question number 1. Flip a coin 10 times. How many heads did you get? Okay, so Sarah said, I flipped my coin 10 times and I got 0 heads. Billy said, I got 1 head. Jill said 1. Sam said 3. Luke said 0. Does that make sense? Or did each person say 12? Well, if they only flipped their coin 10 times, could they have gotten 12 heads? How about this answer? 6, 5, 7, 6, 4, 5, 3. How about these answers? 6, 6, 6, 6, 6, 6, 6. If everybody flipped a coin, are they all going to get exactly 6 heads? 3, 7, 9, 11. Can they get 11 heads? If they only flip a coin 10 times, can they get 16 heads? Okay, I'm seeing some ways we can narrow this down. Are you seeing these ways? I think we can narrow this down. If we're flipping a coin, I don't think we can get 11 or 16, so it's not E. E's out. I don't think we can get 12, so B's out. And I don't think they're all going to get the exact same number of heads, so I think D's out. So our choices now are either set C or set A. And which one do you think makes more sense if we're flipping a coin? Does it make sense that we would get 0 heads in all 10 flips? I don't think that's very likely, but yet 4 people got 0. I don't think that's very likely. Or do you think this data set, 6, 5, 7, 6, 4, 5, 3, 4, 6, 8, that makes a lot more sense to me. How many heads did you get? I got 5 heads out of 10. How many heads did you get? I got 3 heads out of 10. I got 8 heads out of 10. I got 7 heads out of 10. Data set C makes a lot of sense for me. So I think question number 1 is data set C. And the reason is the answers just make sense. They make sense for a coin flip. Right? Not too many, not too few. They vary in their answers. They're not all the same, right? They vary, and they are all under 10, but yet they make sense, right? So I think that's a great choice for question number 1. So now set C is out of the running completely, okay? Question number 2, how many books did you read in the last year? Now, if we ask this question to 10 kids, what do you think? Did they all answer 12? Every single kid that you asked read 12 books? I can guarantee that doesn't happen, right? Did every single kid answer 6 books? Again, I don't think it's very likely that every single kid you ask is going to have read the exact same number of books. So I think we can safely assume that it's not B or D. Do you think it makes sense? Let's look at some of these other ones. How about 3, 7, 9, 11, 6, 4, 2, 16, 6, 10? Those numbers look pretty good. I'm not going to throw it out yet. But do you think every single book or every single kid that you ask is going to have read a book? Have you read a book this summer? Or no, I guess it's not summer, but have you read a book since leaving school? I haven't. I haven't had time to read a book. So I don't know if this data looks the best. It's not horrible. But I think maybe set A would be a better, because reading a book takes a long time. Reading 3 books in a summer, or I guess it's in the last year, I guess. So I guess this data set isn't the worst. Okay, so I'm going to not decide yet, because I can't decide yet. I'm going to say it's either A or E. And I'm going to come back. Maybe some of these other questions will be more obvious. What do you think? Let's just wait for a second. Question number 3. What grade are you in? Oh. Well, let's look back at our instructions. It says 10 6th grade students. These are all 6th grade students. So if you ask them what grade are you in, what are they going to answer? I'm in the 6th grade. 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 No, I'm in the 6th grade. Data set D is the only one that could be because it told us we only asked 6th grade students. So question number 3 is definitely data set D, right? Because all students are in the 6th grade. Okay? So question number 3, set D is now done. Question number 4, how many dogs and cats do you have? Now this one I think is going to help us with number 2. Does it make sense really that kids have 16 dogs or cats? That just really screams no to me, right? Now, does everybody have a cat or dog? I think it's way more likely that people have 0 pets than have 16 pets. Does that make sense to you? So now we have, these 2 questions are very similar, right? We have to think, is it more likely that people read 16 books or that they have 16 dogs? I think it's more likely that they read 16 books in a year. I thought it was just a summer, but it's a year. So actually, I think number 2 is data set E now. And I think number 4 is data set A. And I was leaning the other way earlier, wasn't I? But now that I see this new question, I think it fits better. So I say question E here because there's a wide variety in how many books people read. But there's no limit to how many books people can read in a year, right? People that really love to read very well could read 16 books in a year, right? People read. lots of books. And the data varies. Right? Now that's my reason. You can write whatever you want for your reason. Okay? Let's go back to question number 4. Why did we pick data set A? Because cats and dogs, this person doesn't have either a cat or a dog. This person has one or the other, right? So this just kind of makes sense. You know, when we did this in class a lot, asked, hey, you know, if you have a dog, stand up. Did everybody stand up? No. Did anybody ever say they had 16 dogs? No. Right? So I think that data set was the best. Again, it's kind of like this one. It just makes sense, right? The answers make sense for number of pets, right? It just makes sense, okay? Question number 5, how many inches are in a foot? So if I asked Will, how many inches are in a foot? Will says 12. If I ask Sarah, she'll answer, there's 12 inches in a foot. If I ask Sam, yeah, there's 12 inches in a foot. If I ask Mary, yeah, there's 12 inches a foot. Are any of the people going to say anything different? No, because there really is only one answer to that question. How many inches are in a foot? There are 12 inches in the foot. So that must be data set B, because there are 12 inches in 1 foot. Right? There's no other answer that would be true for that question, right? So awesome. We have now used all 5 questions and we are done with number 1. Okay? Now, in number 2 here, it asks us to look a little further. It says, discuss with your partner, how are questions 3 and 5 different from the other questions? So looking at question D, what grade are you in? And question 5, how many inches are in a foot? Well, those were the ones that had all the same answers, right? So how were those different? That's what made them different. They both had all the same answers. Right? For example, 6, 6, 6, ... and 12, 12, 12, etc., 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 right? No matter who they asked, they got the same answer. So what do you think? Do you think those were very good survey questions? I don't think they're very good survey questions. Because if you're going into a 6th grade classroom, is anybody going to be in a different grade? Probably not, right? If you're asking an answer like, how many inches are in a foot, you're only going to get one answer, right? So that's a good way to know whether it's a good survey question, is if you're getting all the same answers every time, no matter who you ask, it's not giving you very exciting data, is it? Okay. Moving on to activity number 3. And here's our new vocabulary word for this lesson, statistical question, okay? It tells us what a statistical question is, and then it gives us examples of what it is not. Okay, so these questions are examples of statistical questions, and these are examples that are not statistical questions. So let's read through these really quickly. A statistical question: what is the most common color of the cars in a school parking lot? So if I were to look at the school parking lot right now, and I don't really have to ask anybody, but I just look out there and say, okay, there's a red one, there's a white one, there's a blue one, there's a gray one, there's another red one, there's another white one, there's a black one, there's a silver one, right? Am I getting all the same answer? No? Okay. That's a good question. What percentage of students in the school have a cell phone? Well, okay, so in order to get that answer, I would have to ask a bunch of kids, do you have a cell phone? Yes or no? Do you have a cell phone? Yes or no, right? Now, there may only be 2 answers, yes or no, but that's still something I could find a percentage of, right? I could take all those yeses and divide it by the total number of kids I asked, and I could find a percent. So that sounds like a great statistical question. I like that one. Third question, what kind of literature, fiction or nonfiction, is more popular among students in your school? So again, could I ask kids, do you like fiction or nonfiction better? And they would say, I like fiction or I like nonfiction. So yes, there are two answers here, but that's definitely doable in a survey, isn't it? So it looks to me like all these questions that are called statistical questions are good survey questions. They get a variety of answers, maybe not a ton of answers, but even the cars in the parking lot, there's not going to be 47 different colors. I mean, they're going to be white or gray or black or red, right? There's very few colors, actually. But there is a variety in the answers, right? Let's take a look at these non-examples. The first question, what color is the principal's car? Well, if I were to go out to the school parking lot and look at the principal's car, I would have to say the principal's car is black. Now, a couple of months ago, that would have been a funner question because the principal, did you know this? The principal just barely bought a new black car. But before that, her car was green. It was like lime green. Super awesome for a principal, right? But she just got a new Toyota, so it's black now. Hope she doesn't mind me telling you all that. Anyway, so the color of the principal's car is black. Now, no matter who I ask, if they go out to the parking lot and look at the principal's car, they're gonna say black because that's what color it is. Okay, so not much variety in those answers. Let's look at the second one. Does Elena have a cell phone? So I'm only asking one person. Even if I are asking about one person, even if I ask 30 kids, if I'm asking them, does Elena have a cell phone? It's only going to be one answer. Either she does or she doesn't, and everybody's going to give the same answer. So once again, that's not a very good question because it only has one answer. What kind of literature, fiction or nonfiction, does Diego prefer? Again, we're only asking about one person, so it's going to be the same answer. So I think that's the key here. Statistical questions have lots of different answers. Non-statistical questions only have one answer, which make them not very good questions to do on a survey. Does that make sense? So let's look at these questions about these and see if we agree here. Study the examples and non-examples. Discuss with your partner. What do the statistical questions have in common? Or what do they have in common? So we already kind of talked about that. We kind of already did all of these actually. So maybe we're ready to move on. Oh, so what makes a question a statistical question? We just mentioned that, but I want to reiterate it. It means statistical questions get more than one answer. That's the key here. Statistical questions have more than one correct answer. Right? If I see all the cars in the parking lot, that one's red, that one's black, that one's silver, that one's white. Those are all correct answers. But they're all different answers, right? What percentage of the students have a cell phone? Well, 90% of the students have a cell phone. Some of them said yes, some of them say no. There's no right or wrong answer to that, but there's more than one correct answer, right? Fiction or nonfiction, again, those are all great, more than one correct answer questions. Whereas of these, there's only one correct answer. That's just like the questions we saw back here, right? How many inches in a foot? There's only one correct answer. What grade are you in? If you have a class of 6th graders, there's only one correct answer, right? So that makes it non-statistical, okay? Very, very good. Number 2, read each question. Think about the data you might collect to answer it and whether you expect to see variability. This is how many different answers. That's what variability means. It varies, right, in the data. Complete each blank with a yes or a no. It says, how many cups of water do my classmates drink each day? All right. Now, if I were to want to answer that question, what would I have to do? Well, I'd have to do a survey. I'd have to go around and ask kids, how much water do you think you drink in a day? Would you get all the same answer, or would you have variability in your answer? Do you expect variability? Yes, right? Not everybody drinks the exact same amount of water, and does that make it a wrong answer? Absolutely not. He may drink 40 ounces of water and she may only drink 10 ounces of water, but there's nothing wrong with either of those answers, except maybe health, but it's not really a wrong answer. So is this question statistical? Yes. Yes, because their answers vary, right? Let's try the next one. Part B. Where in town does our math teacher live? Well, first of all, I'm not going to tell you where I live. But second of all, is there more than one answer? Do I expect variability in that data? If you were to ask kids, not that they would know the answer to this, but if you were to ask kids where I live, there's only one answer. I only live in one place, right? So no, I do not expect to have variability there. So is it a statistical question? Nope, it's not. Okay, part C. How many minutes does it take students in my class to get ready for school in the morning? Okay, so if I were to go up to say 30 different students and say, how long does it take for you to get ready in the morning? Do I expect variability in that data? Yeah, I think I do. I think Johnny probably takes like an hour and Sarah maybe only takes 10 minutes. Or vice versa, right? Yeah, it varies, right? We expect variation. Well, I was going to say yeah, but I'll just say yes. Okay, so is this question statistical? Yes. Very good. How many minutes of recess do sixth grader students have each day? Now, this is a funny question because we don't get a whole lot of recess. But people tend to forget that we do have recess at lunch, right? So is there going to be a different answer if I ask sixth graders how much recess they have in a day? Well, it really won't vary a whole lot because literally you have that half hour of lunch. Now, yes, you may spend your recess eating lunch, but it is still considered recess. So is there variability expected? Nope. So is this a statistical question? No. Okay. Part E, do all students in my class know what month it is? Okay, so the only way to find out if they know what month it is to go around and ask the kids, what month is it? What month is it? What month is it? What month is it? Do I expect variability in that data? No. Now, may somebody get that question wrong and say May instead of April? Yeah, perhaps. But is that a whole lot of variability if 1 out of 30 get it wrong? No. So I don't expect variability in that. I may get a teeny bit, but I don't expect it because I expect most people will know what month it is, right? So no, that's not a very good statistical question, okay? There is a possibility for different answers, but it's still not a very good one because I don't really expect there to be very many different answers, right? Okay, last one. And this is an activity that you're going to need to print from the Blackline Master. Now, this is just extra practice understanding these vocabulary words that we've been studying. Is it a statistical question, not a statistical question, or are you unsure? And it gives you a chance to classify all these different questions that you have on your paper. In fact, I have that paper here somewhere. Looking at all these different kinds of questions, right? You're just going to put them in one pile or the other. Is this a statistical question or is it not? So it's just practicing that idea of what makes a good statistical question and what makes it not so great at all that we wouldn't even use it, okay? And then once you've decided which cards, which questions go into which pile, you're going to write these letters into your workbook. So statistical questions may be A, D, B, F, and E, and then these ones may be H, I, A, B, and C, whatever they are. You're just going to list those in number 3. Now, if you haven't done this yet, I want you to go and do it, okay? If you have now done it, then in just 1 minute, I am going to go through and give you the answers so that you know what the answers are supposed to be, so that you can check your work, okay? But if you haven't done this yet, go print out this Blackline Master, cut it apart, make your stacks, and then copy your answers into your workbook, and I'll come back to you in 2 seconds and we will go over these answers. Okay? Ready, set, go. All right, we are back, and now I'm going to give you the answers to this last activity. Statistical questions. Question A was statistical. Question C was statistical. Question D, E, F. Well, that's a horrible F. I. Let's see if I'm missing any. J and K. So there are the answers for the statistical questions. A, C, D, E, F, I, J, and K. How many of you got all those right? Give me a big woo woo. So that means the non-statistical questions are B. Oops, not D. Can't put it in both places. B, G, H, and L are my non-statistical questions. Those were no good. Very, very good. I hope we got 100% on that. If not, fix your workbook and then go back and look at those questions and say, why is that not so good? See if you can figure out why those are either good or not so good. Statistical questions. That is the end of the lessons, ladies and gentlemen. Of course, this Are You Ready for More is optional. Honor students, that's for you. I want you to try that, okay? So try that out. Summary. Once again, this is going to go through that vocabulary statistical question one more time. It's going to go through that and talk about a little bit about variability. We know variability means difference in answers, right? I hope we can see this box here. Variability, that's about how different the answers are, right, in our data set. And then, of course, statistical questions are those good questions that have more than one correct answer, right? So go look at the glossary if you need to really fully understand that. Take a look at this summary sheet, and then now we are ready to dive into our homework problems. Now, I hope you notice, and I keep reaching in front of the camera, I apologize for that because I have my computer up there at the top. I want to point out for you as well on practice problem for lesson 2. Again, you are not doing every single problem, okay? You are doing problem number 1, number 2, number 3. You are skipping number 4. Yeah, we're skipping number 4. We are skipping number 5, but you are doing number 6 and number 7, okay? So you're doing numbers 1, 2, and 3. Skip 4, skip 5, but do number 6 and 7, okay? And then don't forget, you also need to do problems 1, 2, and 3 of activity number 1, right? Of lesson number 1, I mean. Only numbers 1, 2, and 3, but don't do number 4, okay? So there are 7 total problems tonight from lessons 1 and lesson 2, okay? So make sure, or maybe there's 8. 3, 4, 5, 6, 7, 8. There are 8 total problems for tonight's homework, okay? So go and give those a shot, and then in just a minute, I will go through these and make sure we understand them all. You guys have done a really, really great job so far. Go do your homework, practice this, and then come back and we'll check the answers together. I know you will do awesome because I know that you will always
do your best because you deserve your best.
Alrighty, you've been so good on this combo lesson today. Let's dive in and grade our homework problems and see how well we did in this new unit. Starting with lesson number 1, problem number 1. Okay, again, you were only supposed to do 1, 2, and 3 in this lesson. So let's dive into number 1 first. It says, Tyler asked 10 students at his school how much time in minutes it takes them to get from home to school. Determine if each of these dot plots could represent the data Tyler collected and explain the reasoning for your decision. So could this dot plot represent 10 students' answers to the question, how long does it take you to get to school? Okay, so again, each dot is a different person, right? And that's their answer. So one person said 5 minutes, one person said 6 minutes, 8 minutes, 2 people said 10 minutes. Does this dot plot make sense? Could it be the data we're looking for? I think so. Yeah. maybe this person gets a ride to school and it only takes them 5 minutes. Maybe this person walks to school and it takes them 20 minutes. Maybe this person rides his bike to school and it takes him 12 minutes. So yeah, there's some variability here, because does everybody walk to school or get to school in the same way and in the same speed? No. So that actually, I think that's a yes. Okay. And then you can explain your own reasoning for that. But basically, it just makes sense with the numbers, right? Let's look at dot plot number 2 here. Now notice our scale changed quite drastically for dot plot number 2. Now it says if this is the question that was asked, this person took 80 minutes to get to school. This person took 120 minutes. That's 2 hours. Look all the way over here. This person would take 300 minutes to get to school? That does not make sense to me. Schools are not that far away from where we live, right? I would say a big fat no. I do not think this dot plot matches that question at all, right? I say no. And again, it's all about those scales. It does not make sense. This is more than 3 hours. It should not take us more than 3 hours to get to school, right? No, that's crazy. So there, you can put whatever reasoning you want for that question, okay? Dot plot number 3. I like these answers. 18 minutes. This looks like 13 minutes, 12 minutes, 10. 3 people did 10 minutes. That's possible. 8 minutes, 6 minutes, 4 minutes. Here's where I have a problem with this graph. Notice how it goes into the negatives. Does this person's answer make sense? If this was the question that was asked, how long does it take you to get to school? Does -5 make sense? How would I do -5 minutes to school? That does not make sense. So I say this is a no, because you have to have something about the -5, right? There's just no way a negative number could be an answer to that question. So that one answer throws this out. There's no way, okay? How about dot plot number 4? Well, I like these answers. Somebody did 5 minutes, some 6 minutes, 10 minutes, 16 minutes, 18 minutes, 20 minutes. It's very similar to the dot plot number 1, I noticed, right? But I do see a difference between dot plots 1 and 4, and that is the number of dots. On this dot plot, there's only 6 dots, but we asked 10 students. So where's the other 4 students? No, this is not a complete dot plot. So that's another no. We're missing dots. Or in other words, we're missing data, aren't we? Yeah, that's not a good one. You can't just stop halfway. You got to do every single dot, right? So guess what? Dot plot number 1 is our winner. It is the only one that is a good dot plot for that question. How many got that one right? Do we agree with that? Super, duper great. Good job. But make sure that you explained for each and every dot plot. I do want a good explanation for each of these, even the no's. Okay? Number 2 now. Here is a list of questions. For each question, decide if the response will produce a numerical data or categorical data. So this is from lesson number 1, obviously. We got to remember those old vocabulary words. What is your favorite breakfast food? Okay, am I going to answer that with numerical data, numbers, measurements, quantities? Or am I going to measure it with categories and words? What is your favorite breakfast food? Categorical. Somebody might say cereal, some say eggs, some might say bacon, right? But all of those are words. Those are all categories of breakfast foods, right? So that's categorical. Part B, how did you get to school this morning? Now this is how did you get, not how long did it take, right? This is how did you get? Car, bike, walking, school bus, mom, right? This is categorical. Okay. Part C, how many different teachers do you have? How many different teachers do you have? Well, I have 7. But Sarah over there, she might have 8 because maybe she has one more elective than me. Does that make sense? So these are actually numbers because it says how many. Those are numbers. That's a quantity question. So that's numerical. Because how many tells us a quantity. Okay? What is the last thing you ate or drank? Oh, so we have to think back. What did I eat or drink most recently? Well, is that going to be a number? Are you going to answer that question with 7? No, that's not numerical, is it? This is going to be categorical. That is definitely categorical because it's going to be a word. Whatever you ate or drank is going to be a word, not a number, right? How many minutes did it take you to get ready this morning? From waking up to leaving for school. Is that going to be a number or is that going to be a word, basically? I think that's going to be a number. How many minutes? That's a quantity again. There's our key phrase, how many, right? So this is numerical. So anytime you see that phrase, how many, that's a big hint that it's going to be numerical, isn't it? Because that's going to be a quantity. Good, good, good. Last one for today is question number 3. Part A. Write 2 questions that you could ask students in your class that would result in categorical data. For each question, explain how you know that those responses would produce categorical. Okay, so you get to be the teacher right now. You get to come up with 2 questions that you want to survey the class about that would give you categorical data, right? Categorical. Either a word, it's got to be a word of some sort. So maybe you can ask them, and I'm not going to write out the full sentences, but I do want you to. How about number of pets? Oh, number of pets is not categorical. What am I saying? But if you just say, what kind of pet? Does that make sense? See how the difference there? If I ask how many pets, then that becomes numerical. But if I ask what kind of pet, that becomes categorical. Okay? Now, again, I could ask, what's your favorite ice cream? Kind or type or flavor, whatever word you want here, of ice cream. Or you could say of books or of movies or of, right? There's lots of different kinds of things you can find the favorite of. But all of those kinds of things are going to be categorical, aren't they? So again, I don't want you to use my examples. I just want you to compare your examples to mine and say, okay, am I on the right page here? Are my answers, like Miss Hatch's, going to give me word category answers? And that's what we're looking here for this question. And then don't forget to explain how you know that they are categorical. Well, this one, because you're going to say either hamster or dog or cat or lizard or fish, right? They're going to be words, answers. How do I know that if I ask kids the favorite ice creams? Well, it's because they're going to answer cookies and cream, chocolate, strawberry, brownies on the moon, whatever it is, right? They're going to be, again, words or categories of ice creams. They're not going to be numbers, right? Very, very good. Let's look at part B of number 3. Write 2 questions that you could ask students in your class that would result in numerical data. Okay, so here's the flip side of this. So for numerical data, just like I almost did for number 1, we could say, how many pets do you have? Whoops, VE. Now that will give us a number answer, won't it? I have 2 dogs, or I have 1 cat, or I have 2 goldfish, right? It'll give me an answer, a number answer, okay? Another example of numerical data, how about how tall are you in inches? Is that something we can measure? It is, isn't it? Again, that's going to give us a number answer because we can measure it. And this one is a quantity, right? It's something we can count. I can count up how many pets. I can measure how many inches tall you are, or how long your finger is, or how tall you are, like how big your feet are. There's so many things you could ask kids to measure, right? And those would all give us numerical data. So I want you to come up with your own questions, but remember to think of things like, will this be a quantity or something I can count? Or is it something I can measure? Because those are the kinds of things that give us numerical data. Okay? And that's the end of this homework because we are not doing number 4. Okay? So let's move on to lesson 2's homework problems. Again, in lesson 2, we're doing problems 1, 2, 3, 6, and 7. Okay? So number 1. 6th grade students were asked, what grade are you in? Explain why this is not a statistical question. Well, the reason here is because if we're only asking 6th grade students, there's only one correct answer, which is 6, right? If I'm asking 6th graders, there's only one answer, 6th. I am in the 6th grade. Everybody's going to say the same thing. That's a boring survey. That's like the most boring dot plot I can even think of, right? Because every single answer is a 6. How boring is that? No, that's no good, okay? So something along those lines for an explanation for number 1. Number 2, Lynn and her friends went out for ice cream after school. The following questions came up during their trip. Select all the questions that are statistical questions. Okay, so we want those that have a variability in their answers, more than one correct answer. How far are we from the ice cream shop? Well, all the friends went together, so their answer is going to be the same. They're all in the same vehicle of some sort. So that one, no, that's only got one correct answer. What is the most popular flavor this week? Oh, well, if you asked everybody their favorite ice cream flavor, are they going to give you a variety of answers? Yeah, I think so. In order to figure out the most popular, you'd have to ask everybody what their favorite is, right? And then looking at those, you can find the most popular. But yeah, I think that's statistical. That's a great survey, isn't it? Let's do part C. What does a group of 4 people typically spend on ice cream at this shop? Okay, so could you do a survey about how much do you spend at the ice cream shop? And would you expect to get different answers? Or would you expect everybody to spend the exact same amount? I don't think everybody would spend the same amount because there's different sizes, right? Some kids only want a small, and then some kids really just want the large, right? They're going to spend a different amount of money. So I think that does make a statistical question, okay? Do kids usually prefer to get a cup or a cone? Well, look, that gives us 2 different answers, doesn't it? So that already answers our question. Is it statistical? Yes, because there's 2 possible answers. And anytime there's more than one, that's a statistical question, okay? How many toppings are there to choose from? Oh, well, if we're sitting at the ice cream shop and they have a menu up on the wall, is that answer going to change? If they have 25 ice cream flavors, they just have 25 ice cream flavors. Or not flavors, but toppings. I mean, your only options are what they actually have in stock, right? So no, I don't think that's a very good one either, right? So my answers are B, C, and D for number 2, okay? Number 3, here's a list of questions about the students and teachers at a school. Select all the questions that are, once again, statistical questions. Let's go through these quick. What is the most popular lunch choice? Do I expect lots of different answers if I ask people what they like for lunch? Yeah, I expect lots of different answers, don't I? What school do these students attend? Well, they're all at the same school. So are they going to give us different answers? Nope, that's not a very good question. That's kind of a duh. We're all at the same school. Part C, how many math teachers are in the school? How many math teachers are in the school? Well, there's always the same number of math teachers in a school, right? So if you're asking all the same kids at the same school and the teachers at the same school, they're going to give you the same answer. There are 7 math teachers. I mean, there's only one correct answer there. Does that make sense? What is a common age for the teachers at the school? Well, oh, so if we were to go ask the teachers their age, well, first of all, don't do that. That's not very nice. But if we were to do that, go and ask all the teachers their ages, would we expect all the teachers to be exactly the same age? No, we would expect a variety of answers, wouldn't we? So that's a yes. About how many hours of sleep do students generally get on a school night? Oh, well, if I were to ask a bunch of kids at school and teachers at school how much sleep they generally get, would I expect to get the same answer? No, because some of you kids stay up all night watching YouTube. And others of you are really good and go to bed on time, right? So I think that's going to have a variety of answers. So I think that's a yes. How do students usually travel from home to school? Okay, well, some of us take the bus, some of us, our moms picks us up, some of us ride our bikes or walk. I've already got a variety of answers, don't I? Right? So I can expect that that's going to be statistical. So my answers for number 3 are A, D, E, and F. Okay? There's 1, 2, and 3. How did we do? We do okay? Let's flip over to the last page. Again, we're skipping number 4 and we're skipping number 5. We're just going on to number 6. Noah's water bottle contains more than 1 quart of water, but less than 1.5 quarts. Let W be the, am I low enough? Let W be the amount of water in Noah's bottle in quarts. Okay, so W stands for water. That makes sense. Select all the true statements. Okay, so we know it's more than 1, but less than 1.5. Let's keep those in mind. More than 1, less than 1.5. Could W could be 3/4. Well, is 3/4 more than 1? Nope. Is it less than 1.5? Yes, but it's not more than 1, so that's out. W could be 1. Now, this is the tricky one. Is 1 more than 1? No. So that's out. W, symbol 1. Now, I didn't give away that symbol. What symbol is that? That is the greater than symbol. So this says W is greater than 1. Is that true? More than 1, yes. But it has to be less than 1.5. So is that enough? No, because it's not 100% true. If I said that W was 7, yes, 7 is greater than 1, but is 7 less than 1.5? Nope. So that is not true. Okay. W could be 4/3. Oh, I like that phrase could be. Could it be 4/3? 4/3 is the same thing as 1 1/3. Is 1 1/3 more than 1? Yes. Is 1 1/3 less than 1 1/2? Yes. So there's our first yes. Okay. How about part E? W could be 5/4. Well, 5/4 is 1 1/4. Is 1 1/4 more than 1? Yes. Is 1 1/4 less than 1 1/2? Yes. So that's another yes. W could be 5/3. Well, 5/3 is 1 2/3, or 1.66, repeating, right? Could that be true? Well, is 1 2/3 or 1.66 more than 1? Yes. Is it less than 1.5 though? Well, 1.5 is 1.5. So this is actually greater than that. So that's a no. Darn, it's too big. W is greater than, this is another greater than symbol, 1.5 or 1.5. Well, 1.5 is greater than 1, but is 1.5 less than 1.5? Nope. So my only answers on number 6 are D and E. Okay. Number 7 got cut off on my paper. I think it's okay on yours, but it is this question. Order these from least to greatest. It's been a while since we've done this, but I think we remember how to do absolute value. Remember, absolute value is the distance that the number is from 0. So how far away from 0 is negative 17? It's 17. How far away is negative 18 from 0? It is 18 units away. That stays negative 18. This is how far away is 19 from 0? It is 19. And then that stays at 20. So now in reality, those are the numbers we're putting in order. So the least of these is negative 18. Second in line is what? 17. I'm going to go back to our original though and write the absolute value of negative 17. So I've done that one and I've done that one. What would be next? Well, 18 is next. So this is what I'm going to write. The absolute value of negative 18 is next. And then 19 is next. So the absolute value of 19 is next. And then, of course, 20 is next. So that's my answer for number 7. Done. We just finished our first combo lesson of Unit 8. Congratulations, ladies and gentlemen. You did a really, really great job on that homework. Let me know if you have any questions on that. Just by way of heads up, Unit 8, we're kind of short on time, so we're going to have to kind of squeeze Unit 8 in a little bit. So we are going to have a couple of these combo lessons, okay? So be aware of that and be okay with that. That's just how it has to go. But I have picked those lessons that really lend themselves. We won't do everything in both lessons. We've done combo lessons before, right? We kind of know how those work. We pick and choose parts of each lesson that are the most important, and that's what we're going to do. Some lessons in Unit 8 we're actually going to skip altogether. They're just not as important. So you'll see Unit 8 is going to be kind of a mixture of combining lessons and skipping some lessons. Okay, so that we can get it all in before our deadline. Thank you so much for working hard. You are now ready to go dive into our combo Check Your Understanding quiz. It will ask you about categorical versus numerical data. It will ask you about dot plots, and it will ask you about statistical questions. So make sure you're ready for that. Go give it a shot. I think you'll do great because I know that you will always
do your best because you deserve your best.